Hey everybody, we are about to do a video and we're going to be doing a test. I got the micro motor hooked up to my DC power supply. We're going to feed 5 volts into it and then we're going to monitor what comes out. So does this produce more out than in? So that's what we're going to find out. So let's get started. So for this, I'm just going to give this a little push to get it started to help it out, since this motor has no torque. Now, as you see, it's got 4 volts going in, and we'll monitor its output, and it should slowly rise as speed increases. Now, at a certain point, it's going to go over what our input is. So as you see, we have 5 volts in, but now we have more than 5 volts out. And as the motor speeds up, we will get more and more output compared to our input. So already we're getting nearly double our output versus input. And as this speeds up, the output will still increase. So we do have a steady 5 volts powering, doubling it. So this by itself, this alternator would be considered a unity device with more out than in. And now we're getting 12 volts out with still 5 volts in, and it's still climbing. And it's still not at the max motor speed yet. 13 volts. 14 volts. And I'm going to stop it there at 15 volts. But you see, we are getting more, and I don't have to power this the whole time to get energy out of it. So not only did we just power that and get 15 volts from 5 volts, we are now still getting that 14 volts. And when you combine time with this factor, think about how long I use 5 volts versus how long and how much I'm getting 13 or more volts out. See, it's still over 12 volts output. That's still outputting. So in this, time is a factor. How long do you have to put input in to get it out? So by definition, this would be considered a unity device. I will continue on with the transformer, but I just wanted to kind of show you the tests involved, to show you input versus output and how that's changing. And then I'll go over the next as we move along.